Hello and welcome to this new episode of Space Weather Videos. Today, we shall be watching a very interesting session of the topic of the structure of the Sun. We, the humans, and all creatures on the Earth, are the part of a larger family. We are the part of the extended family of our nearest and dearest star, the Sun. We all need to know our family, to know ourselves, in a complete sense. So, we need to know about our Sun, as well. We have learnt about how the Sun was born in our last video. In this video, we shall learn about its life and its structure. If you are interested to watch videos on space science and space weather, please subscribe our channel. The Sun is a middle-aged star. It was born about 4.6 billion years ago, and it has enough fuel now to burn for about 5 billion years. You might be surprised to know that the Sun has been getting slowly brighter since it was born. A couple of billions of years ago, the Sun was a little dimmer than it is now. It is an average-sized star. This means there are stars that are 100 times bigger in diameter than our Sun. Truly, those stars are enormous. There are also many stars which are just 1/10 the size of our Sun. The radius of our Sun is about 7 lakh kilometers. It is 10 times the radius of Jupiter, and more than 100 times that of the Earth. It means the Sun can accommodate 1,000 Jupiters in it, or 1 million Earths. The Sun is located in one of the arms of the galaxy, and is placed almost midway from the center of the galaxy to its periphery. The distance from the center of the galaxy is around 25,000 light-years. The Sun also revolves around the galactic center, the circumference of which is therefore approximately 150,000 light-years. As the Sun moves with velocity of about 250 kilometers per second, it will take about 180 million years to make a complete rotation about the galactic center. The Sun is the central star of our solar system, which hosts 8 planets. It is the only star of our solar system. Unlike ours, there are many such planetary systems, which are built up around 2 or more stars. The Sun is the largest object in the solar system. Its mass is 2 × 10⁻30 kilos and contains about 99.86% of the total mass of this solar system. The other 0.14% of the solar system mass is contained mostly in Jupiter, while the other 7 planets contain the remaining mass. Structurally, the Sun is a perfect sphere of hot plasma, made up mainly of hydrogen and helium. The Sun is a population 1 star with 1.4% metallicity. This means, about 1.4% of the Sun's mass is comprised of heavier metals. The Sun also rotates about its own axis. However, the Sun being made up of plasma, have different rotational velocities at different regions. Its equatorial region rotates faster, and takes about 25 Earth days to complete one rotation, while the poles rotate slower and takes about 35 days for the same. The Sun has 5 distinct divisions, from its core to its outermost layer, namely, the core at the center, the radiative zone, the convective zone, the photosphere, the chromosphere and the corona. The core of the Sun extends from the center to about 25% of the solar radius. It is the hottest part of the Sun and of the solar system. The temperature of the core is close to 15 million Kelvin. It is the hottest region of the whole solar system. The core density is 150 times the density of liquid water. It is at this core that the hydrogen nuclei fuses to form a helium nucleus, with consequent release of energy that keeps the sun hot and gives us light and heat. The energy produced by fusion in the core travel through the radiative zone and the convective zone. The names of the zones suggest the way this energy, in form of heat, moves to the upper layers. The high-energy photons released in fusion reactions take a long time to reach the sun's surface. The photons are slowed down by the indirect path taken. A photon may take years to reach the surface from their site of origin, that is, the core. On reaching the solar surface, that is the solar photosphere, it escapes into space as sunlight or in form of kinetic energy of particles. Now, let us make a very simple calculation to find how much mass that the sun is losing to generate this energy. At the distance of the Earth, the solar constant is 1366 watts per square meter now. This radiation being isotropic, that is equal on all sides. The total energy radiation per second is 3.86 into 10 to the power 26 watts. Now, using Einstein's equation of E equals mc squared, where E is the energy generated, and m is the mass used and c is the velocity of light, then we get m as 4.3 million tons. So, the sun loses 4.3 million tons of mass per second to produce the energy it radiates. So, about 3.6 into 10 to the power 38 protons, that is, hydrogen nuclei, are converted into helium nuclei every second for this. The sun's surface, or the photosphere, has a temperature of 5,800 Kelvin. This temperature can be easily determined from the received solar constant, using the Stefan-Boltzmann law. Sunspots are areas that appear dark on the surface of the sun. They appear dark because they are cooler than other parts of the sun's surface. The sunspots are the regions from where the magnetic fields of the sun get out from the sun's surface. Sometimes, there are magnetic field lines near sunspots, which often tangle, cross, and reorganize. This can cause a sudden explosion of energy, called a solar flare. Solar flares release a lot of radiation into space. If a solar flare is very intense, the radiation it releases can interfere with our radio communications here on Earth. The sun's visible atmosphere has a thin, transparent, and reddish-colored layer above the photosphere. It is called the chromosphere. The coloration may be seen directly with the naked eye only during a total solar eclipse. The corona is the outer part of the atmosphere of the sun. It extends millions of kilometers into space. It is most easily seen during a total solar eclipse, but also observable in a coronagraph. The temperature of the corona is about 1,000,000 Kelvin. This leaves the scientists wonder, why and how can be the outer atmosphere get hotter than the surface? The answer, however, is yet to be obtained with confidence. The corona is not always evenly distributed across the surface of the sun. There are cooler and rarer regions on the corona, called the coronal holes. The sun perpetually discharges charged particles at high speed, which are known as the solar wind. The sun also generates its own magnetic field due to the differential rotation of the different radial layers of the sun. The solar wind carries with them these magnetic fields and are known as the interplanetary magnetic fields. Solar flares are sometimes accompanied by a coronal mass ejection, CME, for short. CM is the huge bubbles of radiation and particles from the sun. They explode into space at very high speed when the sun's magnetic field lines suddenly reorganize. The highly energetic plasma, if reaches the Earth, can propagate through the Earth's magnetosphere towards the night side and produce the magnificent aurora near the poles. That is a very brief account on the structure of the Sun. In our next video, we shall bring more interesting facts on the activities of the Sun, its 11-year cycle, and its effects on the Earth. So, keep watching our channel and subscribe us to get notified when we post the videos. If you enjoyed watching our video, please share it with your friends and subscribe us.